All right, let's do some graphing of functions, talk about domain, range, increasing, decreasing, etc., etc. So first of all, this was already partially done by somebody. Let's see if he did it right. Supply the requested information. What's the domain? Well, the domain is always, if you just draw a horizontal or vertical lines, wherever it touches the graph, that's part of the domain. So if you think about this graph, what are the only places that it's not going to touch the graph? Well, it's not going to touch the graph at 4 because there's an open circle there. Sorry, -4. So -4 is not part of the domain. Is 1 part of the domain? That's 1. Sorry, -1. Yes, it is, because there's a closed circle right there. So that's part of the domain. All of these are part of the domain. Yes, 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 yes. Right here at 2, that's not part of the domain. So -4 isn't part, 2 isn't a part of the domain, and everything else is all the way up to, well, wherever it's going to. So it looks like this graph, I'll write it to the right here. The domain, it looks like, will be from -4, not including -4, all the way to 2, not including 2, union from 2, and I'm going to guess it's to infinity. Unless they really did want you to stop at, what's that, maybe 4.5? Or maybe that's 5. Or maybe that's 5. Let's just assume that it's 5. All right, so we'll just pretend like that's stopped. It's hard to tell if there's an arrow there or not because it just kind of ends. But let's just assume that it stops right there. Well, I guess we should technically include 5, so we'll make it a bracket. The teacher may want you to put an infinity there instead. So the range is going to be whatever points are defined for the y values, have y values defined. So imagine drawing horizontal lines. No, 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 no. Yes, 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 yes. Everywhere above 0, it's going to be defined. So the range would be from 0, including 0, because it looks like it touches it right there. The point 0, 0 is part of your graph, so that is part of the range, all the way to whatever the top point is, which looks like 6, or again, maybe it's infinity. So you might want to put to 6 with a closed bracket, or they might want you to say from 0 to infinity if there's in fact an arrow, if you should assume that there's an arrow there. All right, let's talk about increasing and decreasing intervals. Well, an increasing interval would be anywhere where the graph is going up as you're moving from left to right. So when the y values are going up as the x values are going up, that's an increasing graph. Notice that it's from here to here, it's not increasing or decreasing from -4 all the way to 0. It's neither increasing nor decreasing. I'm going to use, let's see, purple for decreasing. So it's decreasing from here all the way to there. And then it's not really increasing anymore. I'll use green for increasing. It's increasing from 0 all the way to 2, and then again from 2 all the way to either infinity or 5. So it's decreasing. So let me change my color back. It's decreasing on the interval from that point. We always use our x value. That point is -1 to 0. It's decreasing from -1 to 0. And you use an open bracket because for increasing and decreasing, because you're really talking about between those, what's it doing? In what open interval is it increasing or decreasing? And it's increasing from 0 all the way to 2, and then again from, so go union, from 2 all the way to, let's say, 5, or again, we could say infinity. And the reason you had to do this right here is because it's not continuous. It kind of jumps. It jumps back down. So it's not increasing from 0 all the way to 5. You can't say that because at some point it's discontinuous. In fact, that's a point we're going to get to in a second. But before we get to that, let's talk about max and minimums. And they're really talking probably about relative max and relative minimums. So again, if we're talking about a closed interval, let's say that this is a point here. Let's just assume that's a point, not an arrow, meaning it stops right there. In that case, there is a maximum there's a maximum at 6, because that's going to be 6 up there. There's a maximum at 6. So you would say 6, and then sometimes teachers want you to say at x equals, there's a maximum of 6 at x equals 5, because the point is 5 comma 6. So there's a maximum of 6 at x equals 5. There's a minimum of 0 at x equals 0. And there's really no other minimum here, because even a relative minimum, because a relative minimum has to be the smallest y value on an open interval. And I can't draw an open interval here to find either a max or a min, because that point is not defined. Whoops. That point is not defined there. Those are both open circles, and since they're open circles, their value is really not there. You can't say that there's a maximum of 4 or a minimum of 3. You can't say that because it doesn't exist. Let's talk about continuity. Continuity means, basically a layman's term for continuity is, can you draw the graph without ever raising your pencil? So it's continuous from -4 to -1, and we're always doing these also on the x interval. It's continuous from -4 to -1. Then it's continuous from, so I'm not sure if they want us to write union, may or may not. So it's continuous from, again, from -1 to 2, it's continuous, but then it jumps. And so then it's continuous from, let me just get rid of this u. I don't know if they want you to use notation like that. Let's just use a semicolon. And then it's continuous again from 2 all the way to 5. And again, notice that brackets, continuity, intervals of continuity, I use open brackets, not closed brackets. There is no symmetry here, because the graph, if you can't reflect it about a line or a point. The x-intercepts, that's just where where it touches the x-axis, and that's at 0, 0. So the x-intercepts are 0, 0, and the y-intercept would be also 0, 0. It's the same one. There's no other y-intercept. There can be another x-intercept, but there can't be another y-intercept, because then it wouldn't be a function. Concavity, it's concave up from -1 to 2. From -1 to 2. Again, open interval, it's concave up. Those other ones are lines. It won't be, there's no concavity. And then finally, end behavior. As x approaches infinity, we'll jump on the graph. Well, I guess this means it does. I guess it means they did want you to draw an arrow here. As x approaches infinity, y approaches, as it keeps going, there's an arrow there, it approaches also positive infinity. And as x approaches negative infinity, well, there's no graph to the left, because that's an open circle and it ended right there. So we would write does not exist for that particular problem.